Hi, everyone. I'm happy to be again this year at Functional Scala conference. And this time I will talk more about sort of high-level architectural stuff, because recently I moved from engineering to engineering management. And mostly it's still going to be focused on tech, but more like around planning and architecture. So I work currently as engineering manager at Captify. It's an ad tech company, so we are building the product in advertising, and it's been almost 4.5 years since I joined the company. Over that time, I transitioned from big data engineer in big data team to big data engineer in activations integrations team because we switched over the way the structure of the teams. And a year ago, I became engineering manager. Also, I'm one of the leads of Women Who Code Kyiv, and I often speak at conferences and meetups. So sort of the expectations that I had in the beginning is that like suddenly I'll become a great manager, and I'll be able to do everything on time and kind of hit all the spots. And actually, it wasn't like a sudden transition in a way, because as soon as my manager proposed me to try it out, we had sort of 6 months of training, trying out things in the team. I was picking up gradually different responsibilities in the team. And then when kind of the date came in, basically, as soon as I came back from Christmas holidays, I became a manager, which was quite sort of sudden still. So what I wanted to sort of hit in terms of the spots is to be a good people manager, to be able to plan things, know enough about the business area, and still to be a great engineer. In reality, it was slightly different. Like definitely management is challenging work, which requires a lot of focus, and it requires a lot of context switch. So in the beginning, I was really struggling with that. And now I have all my to-do lists with different areas, and I'm trying to do better in that area. But mainly, the thing was that it's not possible to do everything on time. So basically, I needed to learn how to prioritize properly. And because of that, my ratio of engineering work decreased gradually. So from 50%, maybe it kind of turned out into 2 or 3 hours a week at best, especially if I spent most of the day in meetings with other teams and with my team. So, but that allowed me to focus more on not only planning for the team and people management, but also about larger technical strategy for the team, which I kind of enjoyed a lot, and enjoyed sort of making the impact larger for the team and the engineering team in general. So the main responsibilities that I have as an engineering manager is people management. So it's performance reviews, one-to-ones, coaching my team members, helping them progress in their roles. The second one is planning. At Captify, we transitioned to this sort of structure of quarterly planning, where product managers create scores for different epics. So we sort of count the capacity for the quarter, and then we try to hit those plans or change priorities if we want to swap some work. And that's why like a lot of work on the engineering managers is to estimate how much time it takes and what actually we can do in terms of do we have enough people, do we have enough existing tech that we can use, or do we want to build something new and it's going to take a lot of time, and dependencies with other teams if that happens. Another one is team strategy and tech strategy. By team strategy, I mean processes in the team. So as soon as I become the manager, more meetings started to happen in the team, but they are kind of making the team more effective, because before that, there was a feeling that people working remotely just join in for stand-up and that's it. And there is no real communication in the team. While now there are refinements where we review the tickets, some tech sessions when we just discuss some solutions, retro sessions to sort of complain as well and just discuss what we can do better, and some ideation sessions to generate ideas to what we can do better technically, sort of adopting new frameworks, improving what we have. And engineering, but as I mentioned, I don't do a lot of that. So mainly because kind of doing engineering work in between meetings is still hard to focus on. So most of the tasks that I've been working on, kind of smaller ones, were technical designs. So yeah, in reality, it feels like this. There is no like specific ratio when you say, for example, that 50% of the day I'm going to be working on this part, 12% on this one. So it never happens this way. It's always about juggling these different contexts and trying to prioritize what works best. So for me, the main one, which I prioritize, is still people management, because when I notice that there is an overload of work and the team is not happy, I'm trying to talk more about it, trying to help them to actually get some rest and not to stress a lot about the work, because that's not only about me caring about the team, but also that helps actually to perform the team better. So the first pain I'm going to talk about is very familiar for everyone, which is tech debt. A bunch of jobs or pipelines that have been hanging in the code base. A lot of people probably don't even know how they work anymore because they were built like 5 to 7 years ago. And but they are stable, so no one cares whether we need to kind of rewrite them or update them. So everything works fine. Let's leave it that way. So talking about sort of where tech debt lies in terms of the types of work, we have product work and tech work. By product work, I mean the features, what we plan for the quarter, what we want to do in terms of business goals. And this is sort of direct work of the team that is visible. And also there is tech work, which can be sort of indirect, because if we work more on adopting new libraries that help us perform better, we are able to actually build new features faster and show better performance. And that's why kind of these types of work are tightly connected, and the perfect ratio is sort of 50-50, but actually it never happens in the team. There is always more focus in specific period of time on one type of work. So what I noticed in my team from quarter to quarter, our kind of ratio of product work versus tech work was slightly changing. And at some point, it just hit sort of this 15% for tech work and 85% for product work, which, well, was driven by the business. So it meant that there were a lot of important initiatives that my team was feeding into, and all of the strategy goals that were set for the company were actually kind of directly impacted by my team. So it kind of made sense why it was happening, but at the same time, over quarters, I noticed that the happiness of the team decreased, and kind of what they told about the feeling of the code base, how some things never change, and we have some tickets in Jira that lie there for months or even for a year. So what we needed to do is to be able to still work on some high priority product work and be able to sort of do some tech work, but not in a way of kind of, well, basically we needed to change the ratio, and the main issue is convincing the people in the business why we need to do that. So difficulty is, again, priority of tech debt, and I would say that this is the main difficulty for different types of work, because in the business, there are always some goals, or there are always some strategies that are driven from the top of the company, and a lot of people, especially in the engineering, perceive it sort of, this is what we need to do, let's do this. And not everyone can see sort of this link between direct and indirect work, especially people who are very focused around business or product, like product managers. Another difficulty is team capacity. So my team is fairly small. There are only 2 Scala engineers and 1 full stack engineer who's transitioning to Scala. And the team is growing gradually, but still it's not that many people that can work on this type of things. And also tech debt could be very boring. Like it's not necessarily about changing the library, but let's update this version, let's refactor this. So, well, engineers don't really enjoy doing that. And obviously we couldn't devote, for example, 1 month of work to just work on tech debt. We needed to be sort of smarter than that. So what I came up with is tech roadmap. So we had our product roadmap with all the things that we needed to do for a year. Obviously, it was quite flexible because some things comes up in the industry, some don't. So we need to adjust to that. But in terms of tech roadmap, I realized that we needed to choose sort of the areas where we are not doing well and try to understand how some of the things that we already talked about before could influence those areas, or if you want to do something new. So basically here, kind of you can see that longer sort of lines is ongoing initiatives over multiple quarters to which we don't devote like specific time, but we're sort of trying to do it all the time, like some versions upgrades. Anyone who sort of touches some library or component should update the version, should create documentation. So in such a way, we don't need to spend like a month on actually writing documentation on everything, but we can do that sort of step by step. Some initiatives are smaller, and here like a month means doesn't necessarily that you need to spend the whole month on it. It's more like sort of a range of time. And therefore, there we can have 1 or 2 tickets, which we just had like in the backlog for a while. And now we can say that this is the end of the quarter and we want to focus on actually doing this ticket because it's important. And there are some architectural initiatives as well. So in my company, we have a virtual architectural team from different engineering managers or tech leads or just interested engineers who contribute to the vision of the architect and help to, well, make it real, because there were quite a lot of huge migrations in the engineering team recently in my company. So basically the virtual architecture team is making it happen. So they are also part of the tech roadmap, which are kind of in blue, and they take most of the time, like 1 quarter or 2, but those are usually planned and the dependencies are defined with other teams. So this is something that influences sort of everyone. So let's talk about some disaster case and sort of the reasons why actually not prioritizing tech debt can cause issues in the future, which are not visible directly, especially for, again, people who are more around product and business. So what we are trying to do and still are in the engineering team is databases migration. So basically, we had like huge monoliths database that multiple teams used, but some of the teams don't really store the data in the database, so they were sort of fine around that, and others use it heavily, like my team, because we push a lot of external data to the tables. And basically, all we needed is just to create small databases per service, so each team could have multiple databases and deploy them in AWS. Which sounds fairly simple, like just moving the tables around. But what we realized in the team that for us, it could take like a year if we want to actually not just move the tables, but to improve what we have in the code base. So yeah, the most simple approach would be just to move all of the same tables. But then we realized that maybe some of them are actually shouldn't be stored in the database. Like, for example, we use Databricks for storage and sort of data warehousing, and for teams like analytics to use it. So therefore, it doesn't make sense to actually store this data in the database if they are not using it. So we created this multiple stages to sort of optimize, to do an optimization of what we have. Sort of, let's stop loading some data that we don't need to the database. Let's create new databases, figure out if the users actually need all of the data. So in the process, we actually dropped quite a lot of tables. And actually, my team is kind of still embarking on this adventure, let's say. So we'll see some difficulties that we might have with all of the stages. But overall, before that, it was still just sort of a huge feat, and it was hard to understand how much time it's going to take with so many tables and schemas. And then when we defined the stages, it kind of became much more clear, and there is some plan on how to do that. But this is sort of disaster case because in reality, if there would be no tech debt or it would be much smaller, it could take like a quarter as it was initially planned, and 1 year, it's a really long time. So that's why kind of this example was, well, very visible for people who were not sure regarding engineering priorities. And that what actually made product manager in my team kind of think more carefully about prioritizing tech work. And the good thing is now that every quarter we review first our tech priorities and then product priorities, and then try to build the roadmap from there. The second pain is around libraries migration. So in the engineering team, we have, multi-repo structure in GitHub, and each of the teams owns their own repo, but still we have a bunch of shared libraries, sort of internal ones between the teams, and that's when the sort of caveat comes in, when we need to upgrade libraries version, when we need to upgrade, for example, some Scala versions in the library and suddenly something breaks. So there's a lot of pain in that area as well. So what we have in the engineering team and what actually helps to drive such initiatives is so-called Scala chapter. Basically, it's sort of a team of people who are interested in Scala from all the different teams at the company. Some of them are even just starting to learn Scala. And because the knowledge sort of about Scala and usage of different libraries can be diverse in different teams, this is sort of a channel to talk and just to discuss the issues that are widespread for all of the teams, and at the same time to help sort of solve those issues and build priorities for them. So the thing that we were trying to do is migrate a set of libraries from PANS to SBT. PANS is a build tool which was created by Google and was fairly used some time ago. So a lot of sort of older libraries, which are 5 years old, were sort of on this build, and newer ones were on SBT. So over time, we realized that we don't actually need PANS anymore. And basically, it was kind of starting to get on the path of deprecation. And therefore, all we needed to do is migrate everything to SBT. But then, as I mentioned, we had like an extreme amount of libraries in our code base. Some of them were simply migrated to SBT. Some of them could be moved to each team if we realized that actually, well, other teams don't use it, so there is no point to have shared code. So the difficulties around there is, well, unexpected build behavior, something that worked really well with PANS could not work with SBT. Another one is, well, shared code in libraries. Someone is deciding kind of to work on that and upgrade the library to SBT, and then something else breaks. Or we need to sort of upgrade in our code base, and then it takes some extreme amount of time except for just changing the version. So I would say that it sort of discouraged people to work on that because they realize that it's not only about sort of ticking the boxes for, yay, we upgraded all of the libraries, but more like you're just sitting there and trying to understand some dependency tree and why this version doesn't work with this one. And maybe there is some coverage of another version. So it's definitely not a fun thing to do. And another issue that we had is embedded structure of the libraries. So basically we could have some sort of, as we call it, Spark utils library, so some things around Spark, and in it a set of other libraries. And then we started to think, do we actually want to have SBT multi-project build, which is not always kind of works well. So there were discussions in Scala chapter, and now we are still on the way of kind of making smaller libraries for now. But we'll still have to, well, come back to this question. So what worked well is, well, having a Scala chapter, because the main issue is around planning this type of work. Like specifically for the business, it looks like, why do you need to change some builds? Like it works just fine. So what's the reason to do that? And for the teams who work as well on kind of product features or more interesting tech features, it's also not the most interesting type of work. So that's why sort of having this space helped when people could just sit down and say that this person worked sort of the most on this upgrade, so let's even it out and move it a bit to another team to work on that as well. And that's why sort of just having this space and the chat and being able to kind of meet up helped with that. Another issue is team capacity planning as usual. It's harder to kind of find someone who will be devoted simply to doing that even for a sprint. And that's why kind of building roadmaps helps, sort of like this tech roadmap, and just saying that we need to do this because our libraries are very outdated and well, we don't want we don't want some accidents in the production because of that. And actually, the thing that helped to raise the priority is blocking of the product tasks. because as soon as the product managers see that this thing that they considered not so important blocks some important product work, they suddenly start to pay more attention to it. So it's kind of more on the negative side of motivation to do things, but it's actually like a great link in between this direct and indirect work that helps people in the business understand why it's important to devote the time to it. The third pain is around Scala versions. So a lot of the jobs in my team are built with Spark. Some of them don't involve Spark at all. And I didn't really kind of counted the number, but this number of jobs somewhere around 60 to 70. So it could be very different to just sit down and update all of them and to hope that all of it is going just to suddenly work without any issues. So we had sort of a versioning nightmare in the general code base for all of the teams. Some of them started to move to 2.13 if they didn't use Spark at all. So for the APIs, it was fine. Some of them were able to move only to 2.12 because, well, Spark or any other issues and some dependencies on the libraries. And there was really old code which still used 2.11. As I mentioned, there are still some components which were built like 7 years ago. And if they work stable enough, no one actually looks into this code. And this is like the major versions nightmare, but there was like a huge list of minor versions differences in the whole code base. So it looked like a huge thing to do when you want to go through the whole code base and change it if only one team manages around 70 to 100 jobs and we have like 8 teams in the company. So the difficulty is mainly, again, about capacity planning too, because someone just kind of sitting down and updating the versions, it's not a fun work and it's not sort of a work that we want to prioritize initially. Another thing is libraries that were shared in between teams. So someone kind of finds time to do that. They update the library, kind of having the best intentions in a way, and then something breaks on the other side for one of the teams because the versions don't really work well. Or when they suddenly start to work on some important feature, they update the libraries and something breaks again. So there were actually situations with some downgrades for those reasons, or kind of building the plan to update in the future because right now it could be like too complex. But overall, kind of shared code is still a big issue here. And also there was a different sort of progress in between teams in the code base. So some teams were able to sort of devote more time. Like, for example, the lead of the Scala chapter is in the fully Scala team. And sometimes because they don't have as much product work, they can devote sort of more time to just experimenting, upgrading versions, decreasing tech debt. And that's why this team sort of progressed more than other ones. And that kind of created difficulties for other teams because now we're kind of behind them. And if they update shared libraries, it can cause issues for us. So kind of this synchronization is important here. What helped here is we've made in my team an ongoing initiative out of that. So as I mentioned in the roadmap, we didn't sort of prioritize that we'll focus on it for a month. We just had like an ongoing initiative that we are doing this every quarter when we find time for that. If we're updating some component, let kind of update the Scala version if we can, and some kind of researches and keeping up to date to what's happening in the industry, because we're still sort of waiting when Spark is going to catch up with Scala versions. Another thing is Teams collaboration. So having sort of a space with Scala chapter and just having the space for the whole engineering team, we were able to get the updates from other teams and just know when something like that happens, which could potentially break our code. So overall, sort of, it's important to manage these collaborations. And constant review of the versions. Like in my team, this is me who's doing that usually kind of by the end of the quarter and before updating the roadmap. I just check if we progressed somewhere around the versioning, like which stage we are on. Currently, most of the versions are 2.12. We don't have finally 2.11 or something like that, but that's only in sort of Teams code. Shared libraries can still be very different. The fourth pane is around pipelines evolution. So I would say that the team at my company kind of entered this stage of huge differences in the last year. So before that, we had a lot of stable pipelines. We were fine with them. They worked for years. And now we are in the stage of sort of let's rewrite everything. And that's why it causes a lot of changes overall. So kind of there is this life cycle of the pipeline. Over time, it can just get deprecated because it's not needed for the business and sort of die, or it can continue to live and it's sort of rotting in the code base, creating issues for other teams, being well outdated in terms of versions, in terms of the approaches to the code, and eventually it's still gonna get deprecated, but it's gonna be like much longer period before it gets there, and in the process, this sort of rotting period is going to cause a lot of pain for the team, and as soon as you need to sort of update anything in the library, it's gonna be really painful. So the approach here was, well, deprecate actually the pipelines because the business sort of focus changed a lot over the years. And that's why we just realized that some pipelines were kind of living for a while. And if they didn't take a lot of costs, we didn't really care if they're running. But actually maintenance is still a cost, which often sort of engineers forget about, because if you see that the pipeline is working, you just kind of know that it's working and that's it. And sort of other 40% were rewritten or planned to be rewritten, and 20 still kind of planned, and we're trying to understand if something is going to change and we'll need to drop them, or we're sort of going to rewrite them in the future. So this is always an ongoing initiative because, again, the business priorities change over time. We can sort of keep in touch with them and figure out what works best in terms of the product and sort of predict the cases when we might deprecate something in the future if we are moving in totally different direction. Also, what happened in terms of the changes in the team is the structure of the Delta Lake. So we tried to provide sort of this data mesh principle with different layering of the data, with bronze layer where we have only raw data that we ingest, silver layer with more refined tables with a bit of deduplication, additional transformations, and gold layer. So gold layer is more with sort of aggregation, more complex sort of transformations built there, and it's fully sort of processed data in comparison to the bronze layer where we have just raw data. So the issue that we had before we sort of started to work in this manner is that the data was not fully available on different stages of its development. So my team mainly works with bronze and silver layer, but sometimes we just sort of provided the access to silver type of data, and actually the users would be interested to see the raw data as well. And that's why sort of with this evolution, some additional components were created because we sort of created intermediate steps in the pipelines, or some jobs were simplified or dropped. And that's why kind of this just vision changed a lot of the setup in the pipeline structure mainly. And another thing that is happening right now in terms of the infrastructure evolution, which also affects a lot the way that components are built, is moving to other sort of other managers of the jobs. So most of the small services in Scala are running via Kubernetes, and we are sort of moving to Amazon EKS, and that's why it requires a lot of additional knowledge and deployment. And a bunch of Spark jobs are sort of moving to mainly Databricks, or will move to Amazon EKS in the future. So that's why it kind of requires more knowledge in terms of infrastructure from the engineers. And it can, again, change the structure of the pipelines if we want to simplify something or drop some steps in the pipelines. So what worked with this sort of changes of the pipelines is, first of all, careful planning, like building phases, and identifying dependencies with other teams and things that we were lacking. Like, for example, some knowledge. If we are moving to AWS, we need to sort of upskill there. Another one is, well, having space for research, not only in terms of devoting the time to it, but also having sort of space in chats or in some meetings where you can discuss your findings and share it with other people to understand if you're moving in the right direction, and just to get reviews on pull requests with some newly kind of shiny research things. And also the last one is sort of reviewing the business and tech needs, because sometimes, well, a good sort of engineer is not only working on the tasks, but also tries to understand the product area and the business and how something that we do in terms of tech can influence that area. And therefore, reviewing of those needs, we could also sort of predict that some pipelines should be moved kind of faster to those environments like AWS or Databricks, or some pipelines are not that important and might be deprecated in the future, so it doesn't make sense to put some effort into it. The pain number 5 is around onboarding newcomers. So currently, like, my team is looking for a new person for the team, but the main challenge recently was around upskilling my team members. I mentioned he for a while was a full stack engineer, and now he's transitioning from JavaScript to Scala, and that's why it's kind of challenging path. So sort of the expectations would be that we have these stages where a person sort of reads some Scala book, takes a course, starts to create smaller tasks and work on them, and then kind of suddenly we have Scala engineer at maybe like intern or junior level, but the person who understands well the code base and can contribute. The difficulties here is, first of all, Scala environment. It's actually the thing that I found the most difficult for newcomers in Scala in general is build tools, trying to understand how it works, and JavaScript is very different in that manner, like how the libraries are defined, how the builds are created. So therefore, it's kind of the most difficult part, because for my team member, it wasn't that difficult to actually start working with Scala specifically, but more like the main question was, how do I actually run this project and see how it works? Another thing is diverse tech in my team. So we have different frameworks. As I mentioned, there are pipelines from kind of older versions, newer ones, and therefore there are different approaches to how they are built in terms of tech and frameworks. And that's definitely a lot to catch up on for the person who's just coming into Scala. Another thing is different coding styles. So again, because we have different components and some of them were written a long time ago, and those people are no longer sort of working in the same team or in the company. Therefore, different coding styles in Scala very discouraging for the newcomers and new team members, because it's kind of harder to understand what's happening in the code if you're just learning and there is a totally different style in another job. And general lack of documentation, like still there is some documentation about the components, but it's not always available for some older pipelines which have been hanging for a while. And there is luckily also documentation from Scala chapter that allows to kind of onboard into Scala. So what happened in reality is, and still happening, is sort of the team members started to look into this book because he found this approach sort of and the way of learning working for him. He took the courses, and the first tasks were mainly around sort of refactoring, dropping some things in the code, deprecating, updating, and trying to understand how it works. Then some small fixes, and over time, he transitioned into building metrics and alerts. Why exactly metrics and alerts? Because it's actually helpful to see sort of how the component works and identify what we want to measure and what we want to alert on in case of any failures or issues. So in such a way, it kind of gives more depth into what's happening inside. And it's still in progress. Like right now, the main challenge is that my team, as I mentioned, heavily contributing to business tasks, and therefore it's definitely kind of going to be hard for a newcomer to just suddenly start writing great Scala services. So it's kind of takes time and requires planning. So overall, the prevention mechanisms here is unify the approaches in the code base, which is again on the tech debt side, on the side on the planning the tech changes. Another one is constant updates of the code base, the versions, the libraries version. So trying to kind of make the best sort of environment for the person who comes for the first time in Scala. Extensive documentation. This is like the hardest probably because no one really likes writing documentation, but that can always be sort of an ongoing initiative. And space for asking questions, sort of like Scala chapter, as I mentioned, or just in the team. So overall conclusions is that team collaboration is very important, especially collaborations in between teams. So having space for discussions, having trust in the team helps to, well, make more performant team. Also, the initiatives which are spanning sort of the whole engineering can be executed sort of faster because they raise the priority of things. Also, tech debt, well, directly affects performance of the team, and the team might not be happy about working on some tasks, or it's definitely going to take more time to introduce some product features because of the tech debt. And documentation is very important, not only for newcomers, but for knowledge sharing in the team, for dependencies in between teams, and to improve overall sort of knowledge and awareness regarding what's happening. So thank you for attention. Here's my contact info. Also, recently I built a Scala course with Manning. So in case you know someone who's starting out in Scala, you can share with them this Scala course. And also I'm Ukrainian, so if you want to support Ukraine and donate, please do. So thank you for attention.